So in this example, I'm going to show you how to solve a horizontal Atwood's problem. So the first thing you want to do is read the problem. So a 10-kilogram block lies on a frictionless horizontal table. To the right of the block is a frictionless pulley, and a 25-kilogram mass is hanging off the table connected to the 10-kilogram block and pulley via some string. What is the acceleration of the system, and what is the tension in the string? So the first thing that I'm thinking is that I'm trying to figure out the acceleration of this system, so both masses, and then I want to know the tension. So I'm solving for A first, and then after I'm solving for force of tension. Okay, so I'm going to visualize the problem by drawing a little mini picture just to visualize what's happening. So I have a 10-kilogram block, and it's on a frictionless horizontal table. So there's my block, it's on the table. To the right of the block is a pulley. Okay, and a 25-kilogram mass is hanging off the table connected to the 10-kilogram block and pulley via some string. So I have the 25-kilogram mass is hanging from the 10-kilogram block and it's connected with string. Okay, so after I visualize the problem, then I'm going to draw a free body diagram for each block. This is a two-mass system. I'm treating each block separately. So the first block is I have the 10-kilogram mass. It's on the table. So I know it's being pulled to the right by a string, so that's tension. I also know that the block has a force of gravity and it has a normal force. I know that those two forces are equal because the block is not accelerating up and down, it's only accelerating to the right, which is in the positive direction. So I know it has a positive acceleration because it's going to the right. Okay, my second block is 25 kilograms. Okay, and it's hanging off the table, so it's not sitting on the table. So I know that I have a force of gravity down, and then I know that there is a string that's holding it there, so I know tension is up. This mass is accelerating downward, so it has a negative acceleration. Okay, so after I have my free body diagrams and I visualize the problem, the next thing that I am going to do is draw Newton's second or write a Newton's second law equation in each direction for both masses. So in the x direction, I'm going to sum up the forces. In the y direction, I'm going to sum up my forces. So in the x direction, I know that I have tension. It's on the block. My mass is 10. And my acceleration. So going back up, I know that I don't know tension and I don't know acceleration because those were two of the questions that I was asking to find. So I have two unknowns in this equation, and that's okay. I'm going to stop there. Then I'm going to go over to the y side. In the y side, I have my normal force plus gravity. And I know that gravity is going to be negative because it's going down in my picture. My mass is 10. But my acceleration is 0 in this example because it's not accelerating up and down. So I know this whole term cancels out. So all I'm left with is normal plus negative gravity equals 0. Okay. Then I'm going to go over and do the same thing for the other block. So for this block, in the x direction, I'm going to sum up my forces. Okay. And I know and then I'm going to do the same thing in the y direction. Okay, there are no forces in the x direction because that block is hanging, so I'm going to get rid of that. And then I'm just going to sum up my forces in the y direction. So I have tension plus gravity. Gravity is going to be negative. My mass is 25. And I don't know my acceleration up and down. But I do know that it's accelerating in the negative direction, so I'm going to put a negative right there, negative 25a. Okay, so once I've done my X and my Y, and I go as far as I can, then the last equation that I'm going to look at is finding the force of gravity in both directions. So I'm going to find the force of gravity for each block. So my mass is 10, and my acceleration due to gravity is 9.8. So I might know the force of gravity on the 10 kilogram block is 98 newtons. Okay, then I'm going to do the same thing over here. The force of gravity on this block is Fg equals mg. My mass is 25, and my acceleration is 9.8. My force of gravity is 245 newtons. So I can then go back and I can plug in my force of gravities. There's no force of gravity in this equation. There is one here, so I could add it in there. But there is a force of gravity in this equation. So I'm going to go back and add it in. Force of tension plus negative 245 equals negative 25A. Okay, then what I'm going to do is, this is a little crazy, but I have two equations with two unknowns. And so I want to figure out the acceleration of this block. Well, I know that the force of tension is equal to 10A. And I know that because they're connected to the same string, that the tensions are going to be equal and that they're going to accelerate as one unit. So if the tension is 10A over here, I can take that and I can plug it right into here because I know the tensions are equal because they are accelerating with and connected to the same string. So I'm plugging 10A in over here. So 10A plus negative 245 equals negative 25A. Then what I can do is I can solve this equation for A. So I'm going to add 25 to both sides. 25A to both sides. That leaves me with 35A minus 245 equals 0. So I'm going to add 245 to both sides. $35A equals 245. And then I can divide both sides by 35. So A is equal to 81.7 meters per second squared. So that's the acceleration of my system, 81.7 meters per second squared. And don't worry, that doesn't make any sense, but I made up the numbers. Okay, so after I figure out the acceleration, we call that a substitution. Okay, after we do that, I'm going to find the tension in my string. So it doesn't matter which equation I use, I'm going to pick one of my equations for tension. It doesn't matter which one I'm going to use because it's one string and the tension is going to be the same in both. So I'm going to pick the easiest equation, which is the one on the left, force of tension equals 10A. And I'm going to plug in my acceleration. I'm plugging it back in and solving for tension. I'm going to multiply my two numbers. So my tension is 817 newtons. Okay, so this is how you solve for the acceleration and the tension of a horizontal Atwood's machine. It's a little lengthy, but it can all be done using Newton's second law.